Welcome to our virtual class in Discrete Mathematics. Today, you will be learning about functions. What is a function? A function assigns to each element of a set exactly one element of a related set. What are the different applications of functions? So this can be applied to various fields like the representation of the computational complexity of algorithms. It could also be applied in counting objects and even in studying sequences and strings. Now, these are some only that we can name of, but I believe there are lots of applications for functions. Now, in mapping or in understanding the works of a function, let us consider x and y as the sets. Now, a function from x to y is a subset of the Cartesian product x times y. And I believe you can still remember our previous lessons about Cartesian product wherein sets are being multiplied. Now, this having the property that for each x is an element or a member of set X. And there is exactly one Y that is a member of set Y with XY as the element of the function. To define it, or we have here to read this, so we have a function, or it denotes a function f from x to y, wherein, as what I have mentioned, x and y are sets. And this is a relationship from elements of one set, this x, to elements of another set, y. And take note that x and y are non-empty sets. So be sure that there are sets or elements inside these sets. Okay, this should not be empty. X is called domain and Y is called codomain of function f. So try to remember this one. And function f is a relation on x and y such that for each x is a member of set x, there exists a unique y that is a member of set y. And such that x and y are the members of the range. Okay, now x here is called the pre-image and y is called the image of the function. We have here, okay, y such that x and y are the members of the function, and this is called the subset of the codomain y. And this is called the range of the function. So if you're going to check for the range of a function, okay, it should be, okay, for the range of a function, you have to check for the subset of the codomain y. What are the elements included in the set y, okay, or in the codomain y? Now, assuming there are, this is for x and this is for y. X has these elements and y has these elements. Now, if for example, we have only 1a, 2b, and 3a, okay, as the function or the set of the function, so meaning to say, okay, so we have here you will notice that C here for y was not included. So that means the range of the function would be only A and B. So whatever elements would be included or would be assigned from the set X, that means those would be the range of the function. So if among these three elements of the codomain Y, only two like A and B are the elements have been assigned, meaning to say the other one here is not included in the range. Therefore, the range would be equal to A and B. Okay, so that is for the range of Y. And take note that a function can be one-to-one or many-to-one, but not one-to-many. Okay, so take note that if we have this so-called function, the function should only be one-to-one, okay, and many-to-one. But there is no such thing as one to. For example, we have here for the X and for the Y. The members of the X or the elements under X, if you have here 1, 2, and 3, and then for Y, we have here A, B, and C. A function, okay, when you speak of function, then that could be, say, 1 here, going here, then another here, then we have here. So that is 1, 1. Okay, that is one-to-one function. Now, when you speak of many-to-one function, so that could be, we have here, instead of having 3A, we change it to, okay, so we change it to this one. So meaning we have here 1A, we also have 3A. So that is one to many, meaning only one, not isa-isa for set X, but many for set Y. Okay, because there are two assigned, two elements under set X that is assigned to set Y. So two, we have here so many. But this, in this way, okay, only one. So that is meant by one-to-one or many-to-one, but not one-to-many. Okay, but not one-to-many, meaning to say, we will be assigning 1A and then 1B, so it is not allowed for the function. Okay, now we go to the example. Okay, we have here, let us assume that the function here from X is equal to 1, 2, 3. These are the elements to Y, which comprises of A, B, and C. So we have here the example of the function. Function here, the set of the function out from these elements. So we have 1A, 2B, and 3A. Now, out from that, okay, we can derive from an arrow diagram of a function, which shows that for the X, we have here 1, 2, 3, and then for the Y, we have A, B, and C. Going back here, so we have 1A. Okay, so the arrow here is 1A. Another one is 2B. So we have here the arrow for 2 and then B. And the last here, we have 3A. Okay, here going here. Now, somebody or others will ask, what happened to C? Why is it C here? Or there is no assignment for C. Okay, now we will tackle that later. Alright? But for the meantime, we only come up with an arrow diagram out from the given sets of function. Okay, these are now the sets of the function. We have here set X, we have here set Y, we have here the elements for set X, we have here the elements for set Y. Now, to derive for a function or the set of the functions, we will assign 1 from x to y, okay? Assigning all of this, okay? Meaning all the elements of set x, the 1, 2, and 3, have been assigned to set y, okay? As reflected in this arrow diagram, okay? So, we were not able to assign for the codomain y of the element C simply because it is not included in the set of the functions. Okay, so that's the reason why letter C or element C was not given an assignment from the X element, I mean from the set X. Okay, now we have here the explanations. Each element of x is assigned a unique value in y, right? Okay, so it's a unique value. We have 1a, the other one is 2b, and the other one is 3a. So there is no duplication there. Another, 1 is assigned the unique value of A, 2 is assigned the unique value of B, and 3 is assigned the unique value of A. For the function f, the elements A and Y is used twice, okay, as you have noticed. So twice, okay, we have 1A and we have 3A. But take note that it does not require us to use all the elements in Y. So it is not necessarily to assign or to use all the elements in Y. Okay, it is not included in the definition of the functions. But provided that all the domains, okay, meaning for set X, all the elements should be assigned. Okay, so that is why we have 1, 2, and 3, and each is being assigned to a unique value from codomain Y. Okay, and you have also to remember that no element in X is assigned to the element C in Y based from the given function or from the set of functions. In other words, the element in X, okay, the element in X, 1, 2, 3, was not assigned to the element C in Y. And it is okay, no problem with that, provided that there is still a unique value for each element of the set X. Now, looking at the arrow diagram, the domain is X, the codomain is Y, and the range of F is AB. So take note of this one. Okay, the range. Okay, the range here, though there are 3 elements A, B, and C for the codomain, but the range here is only A and B because C was not used. Okay, there is no assignment for element C here. Okay, now moving on, we have here another example. Okay, so we have here for set X 1, 2, 3, 4, and for set Y is equal to ABC. Now these are the elements of these two sets. The question is the function or the given set of the function such as 1a, 2a, and 3b. Okay, these three. Take a look at the sets of the take a look at these sets. Is it a function or not? The question is it a function? Given the sets 1a, so we have here 1a, we have here 2a, then we have here 3b. Okay, we derive from this set. Is it a function or not? Okay, so take note that the given set is not a function. So why? Why is it not a function? because the element 4 in set X is not assigned to any element in set Y. Okay, take a look at this. We have here element 1 is being assigned to element A of set Y. 2 is also assigned to element A of set Y. 3 is assigned to element B of set Y, but not 4. Okay, 4 was not assigned to any element in set Y. So that is why the set here is not a function. Okay, take a look at the arrow diagram for that given set. We have here 1, 2, 3, 4. Then we have here A, B, C. Now, 4 here was not given. Okay, the element 4 of set X was not assigned to any element of set Y. Okay, now another example here. We have here 1, 2, 3, 4 are the elements of set X. A, B, and C are the elements of Y. The given set here, we have 1A, 2B, 3C, and 1B. The question is it a function or not? So the answer is, it is still not a function. Why? Okay, so take note of 1 here. The element 1 in set X is not assigned as a unique element in Y. How come it is not assigned as a unique element? Of course, because there are two assignments, okay, two assignments for element 1. Okay, we have here 1 and then A, and we also have here 1 and B. So it's no longer unique. That is why it is not a function. But of course, not only that, because the element 4 is not also assigned to any element in Y. Okay, so element 1, okay, is not a unique element or not assigned to a unique element, and 4 is not assigned to any element. So that's the reason why the given set here is not a function. Okay.